Hello friends, welcome to our channel Knowledge Amplifier. So in my previous video I was showing the project related to handwritten character recognition, right? And what we were doing basically, we were basically extracting different features from the handwritten character dataset, right? For different characters, what are the possible features which we can extract? Like we have considered one particular feature as aspect ratio, right? That is the height along y direction divided by height along x direction. Then duration, then you can take a median as one feature, maybe because all those characters we have seen that were shifted to zero mean with respect to both x and y direction, so there is no meaning in computing mean as feature, right? Because we will be getting value 0 for all the cases. So either you can go with median. Then other feature like I have discussed, that is what is the span. Okay, and for span we have calculated mean absolute deviation, right? That can be another interesting feature. And now in this video I am going to discuss some more important features which you can extract from this dataset, which is having 4 columns. First one is basically time instance. Next column, that is second column, is basically at that particular time instant what is the x coordinate value. Third column will be at that particular time instant what is the y coordinate value, and last one is nothing but the amount of pressure which has to be given at that particular instant for writing that handwritten character, right? So CLC, clear all, close all, warning off, readtable b1.txt. I am taking one small sample where suppose some person has written B, okay, and the dataset already I provided in my previous video discussion. You can refer the links given in the description box. So if we just write x and hit enter, see var1 which is basically time instance, var2 is x coordinate value, var3 is y coordinate value, and var4 is basically amount of pressure. Okay, right? You can simply do what? You can simply plot this. Okay, let me do here. So plot x dot var2 comma x dot var3. Okay, right? Now let's run this. So actually you can see that this is nothing but our English alphabet B. Okay, right? Now we have extracted some features. Now we need to extract some more so that we can provide as much information as possible to our model for training. Okay, so see, one very interesting feature can be distribution of y coordinates and x coordinates with respect to time. Here we have taken in y direction, we have taken y values, in x direction we have taken x values, but we have not used time. Okay, but let me just show you here. So try to understand very carefully how the distribution will look like. So if you observe that suppose this is my y direction and this is my x direction in 2D plane, but this time instead of taking x coordinate value, here I am taking time, which is the first column of our dataset, and in this direction, in y direction, we are taking the x coordinate values for different instance. Now let us try to plot how x coordinate will vary with respect to time. Okay, so when you start writing B, suppose you are starting from this part, obviously as how we write, then see it is going down like this. So in this particular stage, see, initially obviously x coordinate is x direction is not that much changing. Okay, okay, right? So first I am drawing like this because see here straight it is coming, then it is going little bit left side going means x direction value is decreasing, right? Because when we are going towards this direction, that from 0 we are going this direction, that means x direction value we are decreasing more in the basically negative side, we can say. Okay, so here x direction value little bit decreased. Okay, then like that, after doing, suppose we reached here after decreasing, then see here we are going in this direction, positive side. So when you are going to right hand side, x direction value suppose up to this it is increasing, right? Then again we are going to left, so then again it will decrease. So basically here from like this we are going, and then when we reach here again we are turning to left side, and then we are moving in this direction. So the graph will almost go like this, okay. And then after again reaching here we are trying to take direction in the right hand side, okay. That means again little bit x value will increase. So like this kind of thing is expected to get as distribution when we plot this, okay. Now let's check. So here what we will be doing, here we will be doing figure plot x dot var 1 time in x axis, x dot var 2 our x value in y axis. Let's run this and see, as expected. See carefully, initially x direction value constant, then it is decreased little bit, then again it increased, and here also it started increasing, okay. See, if you just match, let me minimize this. See, this one and this profile both are matched, right? So this is one distribution what we can extract from here. How many minimas are appearing, how many maximas are appearing, because when you are drawing this kind of profile for different characters, obviously you will be getting different distribution, and if you compute number of minimas, number of maximas, that not where it is appearing is not that much important. Important is how many minimas appearing, how many maximas appearing, all those things, okay, right? So this is another important feature. Then what we can do, suppose we want to draw the same for our y-axis, okay. Let me just do, okay, right. So here what I will be doing, here I will be doing t, sorry, I hope you can understand this. So here my time is there, and this is y. In y direction we are taking what is the y value possible, okay, right. Now again observe the character b, this one, and we'll try to plot, okay. So let me minimize this little bit and take b here. So how y coordinate is varying. So initially y we are starting from here, and we are continuously going downside, okay. That is y value is continuously decreasing, right. So from here y value is continuously decreasing like that, and we reached here. Then see, we are going in this side. So see, basically we are going again in the upper direction, right. So here after decreasing sharp notch is appearing, then again we are going to upper direction. Then see, after we reaching here we again started going down like this. So basically what is happening, we are going to downside, right. Up to this point we are going to downside, then again we are going towards upper direction. So y value is basically increasing, okay. So basically here up to this we decreased, so that's why this particular part, and then here we took a increase value. Here I have increased, but I have kept the peak lesser than this one, because you can understand this height is lesser than this height, okay. Then here up to this we are going down, all right. So we'll be going down, and then from this part we are again going up, okay. So we are again going up. So like this, or might be this part is not, will not come. We are again going up like this here also. So this should be profile of our y, okay, versus t. Now in this, how many maximas are present, how many minimas are present, obviously that can be featured, that is number of minimas or maximas can be featured, right. So let's do that. So here if I just, let me just first show you the plot of x dot var 1 comma x dot var 3, which is my y direction plot, and I'll be doing evaluate selection, right. And see, this is our y direction distribution, this is our actual character, this is x direction distribution. Here this axis is time axis, this axis is x coordinate values, this axis is time axis, this axis is y coordinate values, right. So basically this is giving us a good idea. Now let's plot the what, correct, let's plot the minima, maxima and all those things. So for that I am computing the indexes of minimas, okay. idxmin equal to islocalmin is the function, as you know. Then here for x coordinates, what is the minima, that is for this particular profile, this one. Yep, for this one, see, minima might appear here and here and maxima might appear here. So let us check x dot var 2. okay, indexes of minimas we have calculated. Similarly, idxmax equal to islocalmax x dot var 3. okay, that is along y direction, what is the minima and maxima. Okay, here let me calculate first for x direction. So for x direction we will be having minima maxima, for y direction we will be having minima maxima. I am just showing with respect to x direction, you can do the other one, right? Now let's plot this. So figure and then plot of x dot var 1. I am again, let me copy from here this one, that is time profile with respect to x direction. Okay, then what we have to do, then we can to show the minima and maxima on the same graph, I am giving hold on and then again pasting the same, but this time I'll be only taking those points which where minima is appearing. So idxmin, and here this will be our idxmin, okay, corresponding points. And here suppose I am taking O as line style, okay, to denote the minimas, and here I'll be copying this line and here I'll be pasting this, and here instead of min I'll be writing max, okay, and this also will be my max, and this will be my maybe S I am giving, okay. You can give any line style according to your choice and giving hold off. Now let's run this whole code, okay. So see this figure carefully. This was our time axis and this was our x direction values it was taking. So this is basically distribution. See, minima is appearing here and here, but maxima square shape it is showing. I hope you can easily visualize. This is square shape, it is appearing here. So one maxima, two minimas. But now we need to calculate these minimas and maximas automatically. So is there any function? Yes, there is function. If you check idxmin, what it is giving us, it is giving us one logical array where it is taking value 1 if it is minima, and rest if it is not minima then it is showing us 0. So you just write nz, number of non-zero element in idxmin, and if you hit enter, see 2, that is 2 minimas are present in the distribution of time versus x coordinate. And nz idx max, if we do 1, that is 1 maxima is present in the distribution, right? So I hope you have understood this, that from the distribution that is time versus x direction distribution or time versus y direction distribution, what we can extract number of local minimas and number of local maximas, which is quite clear that for different handwritten characters it is going to be different, and as a result it can serve, or it has a potential to serve as important feature for training our machine learning model, right? So this is another very interesting feature extraction which I wanted to discuss. I'll be showing some more feature extraction in my upcoming videos. Then we'll be training our machine learning model, and then we'll evaluate that is using validation test set data, right? We'll be doing all this. Till then, stay tuned. Happy machine learning.